Hello Year 6, welcome to your next lesson in our Cool Britannia history topic. This week we're learning all about how fuel and industry changed since the end of the Second World War. We're going to learn about the invention of nuclear power and how this changed the way some industry in Britain was fuelled and the implications of this. Now you already know that the end of the Second World War in Europe occurred when Germany surrendered to the Allies on the 8th of May in 1945. However, the Second World War still continued overseas. Japan remained at war with the USA. At this time, the Americans had been working on developing a weapon of mass destruction in top secret, and the footage we're now watching is of the world's first atomic bomb, codenamed Little Boy, which was powered by nuclear energy, which was developed and then dropped by the USA on Hiroshima in Japan in 1945. This had devastating consequences. It was the highest death toll ever caused from a single weapon. 3 days later, the USA dropped another atomic bomb on the Japanese city of Nagasaki. 3 weeks later, Japan formally surrendered and the war was officially over. You can see here on the footage the recognisable mushroom-shaped plume caused by the dropping of an atomic bomb and some of the devastation caused to the city that it landed on. Britain was also keen to become a nuclear power, and in 1952 Operation Hurricane was the first test of a British atomic device. A plutonium implosion device was detonated on the 3rd of October 1952 in the Montebello Islands in Western Australia. We're going to watch this test on the video footage taken at the time.
Off northwest Australia are the Montebello Islands. Far beyond normal shipping routes they lie, and until 1952, only pearl fishing boats entered the blue waters that lap the cliffs surrounding their shores. Barren, unfertile rocks where no man lives, buffeted by winds blowing in from the ocean, scorched by a dazzling sun that beats upon her empty beaches. This was the place chosen to explode Britain's first atomic weapon. Early in the year, equipment began to arrive from Britain for the great experiment in ships of Her Majesty's Navy. On board were men of the Royal Engineers and the Royal Marines. Upon them fell the task of handling the delicate equipment and preparing the islands for the dangerous test. Through many months they worked, and then came Dr. Penny to direct the whole operation and with his fellow scientists to make his final plans. But there was still much to be done. Many roads had still to be laid for the heavy transport and materials to be moved into the actual site for tests. The shelters, similar to wartime Andersons, were erected in the immediate blast area, and concrete block structures were built at intervals from the center of the explosion. Finally, all preparations were completed, and the last group of scientists left the islands. All was still on shore. The islands were deserted. Yet somewhere in their midst rested the atomic weapon, second only to the hydrogen bomb as the most destructive weapon the world has ever known. Out at sea, on board the Campania, Dr. Penny and his team made final adjustments to their instruments in the control laboratory.
Interesting to know that the HMS Campania, the ship you see here that the atomic device was placed upon for the test, sailed here to Australia from our own local dockyard in Portsmouth in 1952.
Tick away. Thousands of tons of water, mud and sand blackened the gigantic fireball. Like a huge boiling cauldron, the cloud billowed upwards to a height of 10,000
We now know
feet
that atomic
within 2
energy
minutes.
causes radiation which has terrible effects upon people's health if they're not properly protected. However, at this time this was not known, and you can see here that the soldiers who were present at the test had no protective equipment at all. They're dressed in shorts and were simply told to turn their backs to the blast.
Ship carrying the weapon had been vaporized. Smoke rose higher and higher, the strong wind twisting and sprawling it until it was a mile wide at its center and about 2.5 miles high. To Dr. Penny and his team, great credit is due for this mighty British achievement. The spectacular success of the operation furthers our hopes of peace, for it seems that by the possession of such deadly weapons, peace can be maintained in this troubled world.
After the war ended in 1945, we continued to work on harnessing the energy from nuclear fission to make electricity. This new energy source was seen as a cleaner and cheaper way of producing power, as it doesn't create any greenhouse gases like fossil fuels, coal, oil and gas do. The United Kingdom established the world's first civil nuclear programme, opening a nuclear power station, Calder Hall, at Windscale in England in 1956, and was officially opened by Queen Elizabeth II on the 17th of October of the same year. It was the world's first power station to generate electricity on an industrial scale from nuclear energy. We can see from the footage here Queen Elizabeth II opening Calder Hall.
That I now open Calder Hall, Britain's first atomic power station.
Hailed as the dawn of the atomic age at the time, it produced electricity for 47 years and stopped generating power when it was decommissioned in 2003. When the station was switched on, nearby Workington became the first town in the world to receive heat, light and power from atomic energy. It wasn't without its problems though, as Windscale caught fire on the 10th of October in 1957, causing the worst nuclear accident in Great Britain's history. It was ranked in severity at level 5 out of a possible 7 on the International Nuclear Events Scale. The fire burned for 3 days and there was a release of radioactive contamination that spread across the UK and the rest of Europe. No one was evacuated from the surrounding area, but there was a worry that milk might be dangerously contaminated. Milk from about 500 square kilometres of nearby countryside was diluted and destroyed for about a month afterwards. Nuclear power is not without its drawbacks, and we'd like you to find out more about this for your history task this week. I'm showing you your sheet here that you'll find on the Google Drive, which will help to start you off with the task. Firstly, there's a video for you to watch explaining the process of making nuclear power. The link is the first one in the description below and looks like this. Secondly, there's a video for you to watch explaining why nuclear power can be dangerous. Again, it's linked in the description below and it looks like this, so that you know what you're searching for when you look on YouTube. Last video that you're going to need for your task, which explains the other side of the argument and is also linked in the description below, tells you all about the benefits of nuclear power as an energy source. Once you've watched the 3 videos, your task this week is to sort the arguments for and against nuclear power that are on your task sheet, which I'm showing you here and that you'll find on the Google Drive. It looks like this. You could cut out the statements and place them either side of the for and against sheet, or if you don't have a printer, there's no need to. You'll see that all of the statements are numbered, so you can order the numbers either side of any piece of paper before making your decision. And the question that we'd like to pose for you is nuclear power a good source of energy, or do the dangers outweigh the positives? Good luck with your home learning this week, Year 6, and we hope to see you very soon.